Question 6, motion on an inclined plane. A block B of mass 2 kilograms lies on a rough inclined plane sloping at 30 degrees to the horizontal. A light rope inclined at an angle of 20 degrees above the line of greatest slope, this one here, is attached to B. The tension in the rope is T. There is a frictional force F acting on B. The coefficient of friction between B and the plane is mu. Part A, it is given that F is equal to 5 and the acceleration of B up the plane is 1.2 meters per second squared. Roman 1, find the value of T. Now, what we are going to do here is to first put the forces that are acting on this particle. So we have this one here, which is mg cosine. Okay, m is 2. Actually, let me just put 2g cosine of 30. Then we shall have here 2g sine of 30. Okay, when we resolve the what? The weight. So this 2g here, this is the same theta as this one here. Then closing is a cosine. Opening is a what? A sine. Now there is no more reaction here because this one is directly connected to the plane. And then close this t here, resolve that force. So we shall have t cosine of 20. And then when you open it up, here we shall have t sine of 20 degrees. Okay, then this system is going up here and the acceleration is 1.2 meters per second squared. Now, of course, we are going to use F is equal to ma. From the diagram there, you can easily see that we don't have vertical motion. So this one here is R is equal to 2g, then the cosine of 30. Now, using F, so using F, which is equal to ma, then T, this force that is now taking this particle that side, T cos 20 minus, was this one a rough plane? They said the coefficient of friction between B and the plane is this one here. Okay, so F is 5. If F is 5, then we are going to have minus, there is the F here, 5, then minus the mg sine, that is 2g sine of 30 degrees. Now, the frictional force, I would have put here mu r. Okay, I would have put here mu r, but this mu r is the F here. Okay, it's already given in there. You see this frictional force F, which is given as 5. So that is that. Then it's equal to, the mass is 2 times the acceleration 1.2. So T here is going to be equal to, this is 2.4. So I'll have 2.4, then plus 5, then plus, this one will be 20, then times a half, that will be 10. So plus 10, then out of the cosine of 20. So this one is actually going to be, what do we get here? This is 15 plus 2, that will be 17. So we have 17.4 out of cosine of 20. So that is the exact value of T. But to 3 significant figures, this one we can write it as 17.4 out of cosine of 20. And that one is going to be 18.5. 18.5 newtons. This one is 2, 3 significant figures. Then Roman 2, find the value of mu. Now, when we look at the forces resolved vertically, okay, vertically or perpendicular to the plane, there is this r plus this t sine 20. Then it will be equal to that. So we shall have r plus t sine 20. Then it is equal to 2g cosine of 30. So meaning R is going to be equal to 2 times G cos of 30 is root 3 over 2, then minus our T sine 20, we shall have 17.4. That's why I first wrote it here as an exact value rather than using this one, which is rounded off. So out of the cosine of 20, okay, then sine 20. So in other words, R, of course, sine over cosine is tan, right? Now, this one will cancel with that. So we have 10 root 3. 10 root of 3 minus 17.4 tan of 20 degrees. So I keep this as my R, okay? But frictional force, we know that it is equal to mu R. So if F is equal to mu R and they want us to find mu, so mu will be equal to the F, which is given as 5. Then we divide by R, we have gotten here as 10 root 3 minus 17.4 tan of 20. And then to 3 significant figures, what will be the mu? 5 divided by 10 root of 3, then minus 17.4 tan 20. That is 0.455. 0.455. 3 significant figures. That is that. Part B, it is given instead that mu is equal to 0.8 and T is equal to 15. Determine whether B will move up the plane. Now let me first draw again the diagram here. So we have this particle here. We have R here. Then this one is 2G cosine of 30. Then of course here we have 2G sine of 30. Now we don't know the F, okay? The angle here is 30 degrees. Then remember we had something like this. So the T here is given as 15. So meaning here I have 15 sine of 20. And then here, remember this one was 20. Then here I have 15. It is the one that is supposed to be here, okay? But I'm just putting it down here. 15 cosine of 20. Now, vertically, R plus 15 sine 20 is equal to 2G cosine of 30, okay? These ones going up are equal to the and going down. We don't have vertical motion. So R is going to be, of course, this is 20 times root of 3 over 2. That one will be 10 root of 3 minus 15 sine 20. Okay, then what is the value of F plus, remember F is actually mu R, okay? Mu R. That is the F, then plus 2G sine 30. Which value do we get here? So mu is given as 0.8, then times R, which is 10 root of 3 minus 15 sine of 20, then plus 2 times 10 times a half. So what do we get all together here? 0.8 into 10 root 3 minus 15 sine of 20. Then plus 20 divided by 2, that will be 10. So plus 10, what do we get? We have 19.75, 19.75, 216474. Now let's look at 15 cosine of 20. What does it give us? 15 cosine of 20. 14.09538.931. Now, since this force here, the value here is less than this value here, that means the particle cannot move up the plane. This one is bigger than this one. As simple as that. Okay? So I would just say since 19.75216474 is greater than 14.09538 then B does not move up the plane. Alternatively, you could find the new value of mu. Alternatively, you could use this one. Resolving forces horizontally, we have F, then plus 2G, sine of 30. And then we say this one is equal to 15 cos of 20. So this is, remember, mu r. So plus the 2G sine of 30, then is equal to this 15 cosine of 20. So our mu is going to be equal to 15 cos of 20 minus 2 times 10 times 0.5. Then we divide by r, which r is 10 root 3, is 10 root of 3 minus what? 15 sine 20. 15 sine 20. So we get the value of mu here. That comes out 15 cosine of 20 minus 10. Then down here we have 10 root 3 minus 15 sine of 20. 0.33595735. Okay, so this value here we have gotten is way below this one here, which is given. So I would conclude and say since 0.33595735 is less than 0.8, okay, the particle, the block does not move up the plane. Okay, the frictional force would have been 0.8 to move up. You get it? But for this case, by using the 15, which is given to us as the T, we are seeing that what we are getting here, the frictional force that comes from there, the coefficient of friction is this one, not 0.8. So the particle cannot move. But if it was higher than the 0.8 given, automatically the particle could move up the plane.